this video, we're going to take a look at the linked list data structure. So we'll talk about the different methods that we can do with it, and then we'll also implement this in Python. So what exactly is a linked list? Well, think of an array, except that every piece of data is going to be linked by what we could call maybe a chain or some sort of connection. So for example, I might have, let's call this a head node. It doesn't actually represent anything. And this is chained to our first node. And each circle here is going to represent a node. So this node might have some value, maybe like a 1. And then it's linked to some other node. This might have a 3 in it, maybe to some other one. This has a 6. This is maybe a 10, and so on and so forth. So this is going to be at index 0, 1, 2, and 3. And we have so on and so forth. So if we look here, the way to get to any of these items is not really as you would see with the normal array. With a linked list, you always have to start at the beginning, especially with the singly linked list. So in this case, we have to start at the beginning here. And if we want to get to index 3, let's say, then I have to go here, and then I have to go here, and then I have to go here, and then I can get to index 3. So I have to go all the way along the chain, starting from that very first index, or from that very first head node. And I can't directly jump to that item like I can in an array. Now, what exactly are some benefits of using linked lists over array? You might see a benefit if you want to be able to quickly insert items in between two items in a linked list, or if you want to remove items easily. Because with an array, if you're going to insert or remove between existing items, then you're going to have to shift everything from the right forward if you're going to insert, and you're going to have to shift everything from the right down if you are going to remove. So let's take a look at the different functions that we can use here. So the first one is the get function, and we saw right here, to be able to get something, we have to start all the way from here and proceed to the right until we get to that index. We can't directly jump to it. So it's pretty straightforward. All we have to do for that is just loop from the beginning, just keep going to the next node, and so on and so forth. Now the one after this is append. So append is going to be where we add to the end of our linked list. So we can just write append here. And let's say I just duplicate our linked list that we have here, and I'll also copy the indices that we have too. So if I want to add to the end of this list, again, I'm going to have to go all the way to the end of this linked list. So I'll traverse all the way there. And only then can I say that this node dot next node is going to be equal to this new node that I create. So I can create that new connection. And this might be some value, maybe 7. And then if I want to append another one to the end, I will have to start all over from here. So I'll have to go this way and then this way and so on and so forth until I get to the end of this new linked list with the 7 at the end. And then I can add a new connection. And that might be an 8. So that's append. Now what about insert? What if I want to insert in between two items that are existing in my linked list? So let's scroll down and let's just duplicate this once again. So we want to insert. And how are we going to insert? So let's say I want to put a new node in between this 3 and the 6. So I want to put a node at index 2 so that my new linked list becomes 1, 3. And then let's say my new item is 4, and then 6, and then 10. So how do I make this shift? So what I'm going to have to do here is I'll have to iterate from the start all the way to the node that is 1 before the index where I'm going to insert my new item. So I'll start here, and I'll keep going until I get to here. And so this node right here that has a value of 3 is right before the node with a value of 6. So I'm going to say that 3. So 3's next node is currently set equal to 6. Well, I'm going to say that I'm going to create a new node. This is 4. And I'm going to set 4, that next one, equal to 6. So 4 is going to point to 6. And then once I have that, I can remove the pointer from 3 to 6, and I can point from 3 to 4. And so that effectively creates this transition right here. So that's how I'm going to do insert. Now let's talk about removing. So removing is very similar. So let's just copy this one over once again. And we'll move this down here. So we want to remove. So let's say we want to remove this 6 right here. We don't want the 6 anymore. So again, we're going to iterate from the start. So we'll go here. And then here, And we'll stop right here because this node is previous to this node right here, and we want to remove the 6. So now what we're going to do is I'm just going to draw out what this looks like on the side. So we have 6 and then we have 10. So when we remove this 6 node, we want to make sure that we don't lose the 10 node or anything that's after. So what we'll do is we're going to say that this right here, this is going to have some next variable that's assigned to 6, and that's how we have our pointer. Well, we're going to reassign our pointer to this. So if we say 3.next is equal to 6.next, then that effectively gets rid of this connection right here, and we transitioning directly from here to here. And that's how we can remove. And then the last thing that we want to do is just iterate through our list. So I can duplicate this one more time. And so we want to iterate through here. And if I want to iterate through my entire list, that means I just have to start from the beginning, just like we were doing before. So go here, and then I keep going until I get to the end. And now I'm at the end and I've printed all the items, or I've done whatever I wanted to do with all the items in my list. So those are those key functions that we're going to use. We're going to get something from our list, we're going to append, we're going to insert, we're going to remove, and we're going to be able to iterate. So let's go ahead and implement this in code.